Let me copy this problem. So 21 over 25 times 35 over 189 times 245 over 63. At the first glance, this is terrible. I was just looking to see. Okay, good. So at first glance, this looks awful. But if you keep in mind that I said please simplify first, you will see it will not be difficult. Okay. First of all, I'm looking at these two. They caught my eye because they end in 5, and they're easy to simplify. 25 divided by 5 is 5, and 35 divided by 5 is 7. That's my first step. Then what I see is the 7 with 63. I simplify the 7 by 7 and 63 by 7, and I get 9. Now it's about time to rewrite, because I already have crossed out several things. Let's rewrite. 21 over 5 times 1 over 189 times 245 divided by 9. This is the stage we're in right now. Any questions? Any questions so far? Okay, now I see 21 and 9, and they are divisible by 3. 29 divided by 3 is 3. 21 divided by 3 is 7. I also see the 5 with the 245. They both end in 5, which means they are divisible by 5. 5 divided by 5 is 1. And 245 divided by 5 is 49. It's about time to rewrite the whole thing because I already have crossed out different things in there. So now I have 7 over 1 times 1 over 189 times 49 divided by 3. Good. So now I want to see if 189 is divisible by 7. It's my last chance. 7 and 7. I don't know. So when I divide 149 by 7, 189 by 7, what do I get? 14 and then 49. So this is 27. I like it. So 7 divided by 7 and 189 divided by 7 is 27. And this is it. There's nothing else I can do. So what is the final answer? Is 1 over 27 times 49 divided by 3. I know how to multiply fractions. 1 times 49 is 49, and 27 times 3 is 81. Now the question is, what if I messed up? How do I know that this is correct? Here is how I check my answer. Ready for this? So I go to the graphing calculator, and I do this. But be very careful. Parentheses for the numerator. And I go back to the original problem, 21 times 35 times 245, close, divided by, open again, 25 times 189 times 63, close. This is what I had in the original problem, 21, 35, 245, 25, 189, and 63. I click enter. Whatever, I get some gibberish. But if 49, my simplified form, divided by 81, will not give me the same gibberish, then I say, oopsie, oopsie, oopsie. It has to be identical gibberish. If it isn't, then I'm in trouble. And this is how you should check your answers. I refuse to enter an answer before I check it Why will I lose points on a problem that is really a piece of cake? It's cumbersome because I have to rewrite it and find factors and simplify, la la la. But once I'm done, I should always check my gibberish. If it's not the same, then I start from scratch. Any questions? Any questions?
I have a question.
Please.
Okay, so at the end of the very last one, you said 1 over 27 times 49 over 3.
Yes.
Okay, so how come you couldn't factor the 7 from the beginning and that 49 over on the other end of the equation?
Oh, of course you can. I mean, you mean factor out
Meaning like, okay, in stage 2, where you cross out the 21 and it's a 7, and you cross out the 245 and it's a 49?
Mm-hmm.
How come you couldn't simplify it even more to make that?
You mean here the 7 with 189?
No, right where you have the 7 on the top, right where you pointed at, there's a 7, okay, and on the other end of the problem, there's a 49. On the where the 2, you cross out the 249.
Got it.
The 49 divided by 7 is 7, so why couldn't we factor
Right.
that?
Never, ever simplify numerators. I said that many times. Never, ever simplify numerators or denominators by themselves.
Okay.
You can only simplify dividing the numerator by something and immediately the denominator by the same thing.
Okay.
These are multiplied. These are divided. I can simplify them, but I cannot simplify from here. It's like you're telling me that you have $100 in your pocket, and I say, no, you have 50. I just decided to divide the numerator by 2 because I want to.
Okay.
So the numerators cannot be simplified. When I take something away, I take something from a factor from the numerator with a factor from the denominator. So in other words,
cross the wire.
Exactly. So in other words, 20 divided by, let's say, 100 and multiplied by 10 over 2, it means that I'll simplify this, and I have simplified this, and I have 1 over 100, but it's not possible. I still have 200 over 400. I'm sorry, 200 over 200, which is 1. I don't have 1 over 100.
Okay.
So that's why I'm begging my students to pay attention and look at the videos, because we are tempted to do things without thinking till we understand the rule, and it becomes second nature. It takes a while. Absolutely. I don't see, yes, I do see one more thing that I'd like to cover, and that let's move on, which is, given the replacement values, so we have x equals negative 2/3, and we have y equals 9/2, and they want us to evaluate either xy or x plus y. Which one would you like? I would prefer x plus y, because let's do both. Okay, so I'm asked to find xy. I will write negative 2/3 multiplied by 9/2. I don't need to put parentheses around 9/2 because it's a positive number. I refuse to multiply before I simplify, and we can only simplify a factor from the top with a factor from the denominator. Never numerator with numerator, and never denominator with denominator. The top is simplified by 2, the bottom is simplified by 2. The bottom is simplified by 3, the top is simplified by 3. So therefore, the answer is negative 3. Now when we want x plus y, I copy negative 2/3 and I copy 9/2. And I know now how to add fractions. And this is the simple situation, because 3 and 2 do not have common factors. because they do not have common factors, then the least common denominator will be
6.
indeed. Now I need to remember what I just did, meaning I took the liberty to multiply 3 by a quantity to get 6. I must apply the same treatment to the top. Otherwise, I will never get the correct answer. So what is the treatment that I have to apply to the top? As a factor, of course, not adding or subtracting.
Times 2.
Times 2. Now, 2. I took the liberty to multiply by something to get 6. I am forced, obligated to apply the same treatment to the top.
Multiply by 3.
Excellent. Now be very careful at this point. We do multiply 2 times 2, but we have to take into account the sign in front, which has to be connected to the top, not to the bottom. So this is 2 times -2, which is -4. And now plus. Now I need to multiply these two quantities, and this is 27. Would you be tempted to simplify the -4 with 6 or 27 with 6? Please say no. I would like to hear everybody say no. Okay, so then the numerator is 23 and the denominator is 6. If we're asked to take the integers out, we will say 3, because that's 3 times 6 is 18. And the remainder at the top will be from 18 to 23. That's it. So this is the improper fraction, and this is the mixed number. Good. I think I'm happy with what we had accomplished on this. So in 2.2, I did not wait till 2.2. 2.2 is mostly complete. We know how to multiply fractions, multiplication of fractions, reciprocals, how to divide fractions. We already talked about that, multiple operations, and evaluate algebraic expressions. We just did this a minute ago, and solving equations containing fractions. Okay, so let's continue with, so you are responsible for 2.1 learn and practice 2.1. We're not going to be able to finish everything here. So do the learn of 2.2, yes, but we are going to look at, we still have about 15 minutes, no, we have 20 minutes. Okay, look at this, gee whiz. Okay, good. So this is 2.3. Adding and subtracting fractions. We know how to do this, so I'm just going to move on to, if the denominators are the same, there is nothing. It's 22 over 8, and you have to simplify. Now let's move on to real issues here. These are not real issues. Okay, yeah, this is a good one. So let's take a look. 2/3, I'm going to change the z to x because my z is confusing. So 2/3 x minus 6/3 x. Here, there is really nothing because, basically because the denominator is the same. So I will copy the denominator. And I will rewrite the numerator in this way. 2x minus 6x. Remember, x is x over 1. So x is connected to the top, not to the bottom. So then 2x minus 6x. Will you be tempted to simplify 6 and 3? No, because 6 is part of a term. It is a factor, but it's part of a term. So I will never try that. So then the numerator is -4x over 3. And we have to write it with the negative sign in front. It's a must. So the final simplified form is this. because the numerator is negative, the denominator is positive, the whole fraction is negative. So I have to carry the negative sign in front. Good. So this is rewriting as equivalent fractions. We know how to do this. Yes. Yes. Rewrite each fraction with the least common denominator. So let's assume, I'm going to change this problem a little bit. And 1/9, 1/6, and 1/2. Perfect. So just tell me what symbols. Do you want to add them all? You want to subtract some of them? Just choose any symbols you want. Positive, negative, whatever you want. You choose. You want addition between 1/9 and 1/6? You want subtraction? Which one do you want?
Division.
No. We're talking about the least common denominator. But we can divide. No. That's fine. That's fine. Let's divide first. Yeah, it's a different example. Fine. But we are focusing now on the least common denominator. But that's okay. So we want division here. What do we want here?
Multiplication.
Okay, perfect. Do you want any parentheses anywhere or not? Because that changes the. Say it again.
Well, no, between 9 and 6.
So you want parentheses here.
Yeah.
Okay. There was no need of the parentheses here. I thought that maybe you wanted here because
Oh, yeah.
this already says we have to perform division and multiplication from left to right if there are no parentheses. If there are parentheses and if you want to put them here, then we have to do multiplication first. So it's up to you. You want to keep it as is or just multiply, divide and multiply?
No, we can change it.
So you want to change the
Yes.
parentheses here?
Sure.
Okay. So 1/9 divided by 1/6 times 1/2. Good. So in that case, we have to perform the product first. Otherwise, from left to right, with no parentheses or parentheses here from left to right. So the answer will be different. Good. So I have 1/9 divided by. In order to multiply, very easy, 1 times 1, 6 times 2. Now the final operation here is division. So I have to copy the first fraction as is. I have to change the division into a product. And I have to multiply by the multiplicative inverse. Do not multiply before you simplify. Only apportion a factor from the top with a factor from the bottom. Never simplify numerators, never simplify denominators by themselves. Only a factor from the top with a corresponding factor from the denominator. 12 divided by 3 is 4. 9 divided by 3 is 3. What is the final simplified form?
1/3.
It's 4/3, or if you want to change it into a mixed number, 1 1/3. However, what we had in mind, which is a perfect example here, it's very good to practice, 1/9, 1/6, and 1/2, we either want to add them, subtract them, or a combination. So what symbol? Addition or subtraction between the first two fractions and between the last two.
Subtraction and addition.
Okay, so we want to subtract and then we to add. Perfect. We cannot add and subtract fractions without finding the least common denominator. What is it? I don't know. I take 9 aside and I write its prime factorization, which I know is 3 squared. I take 6 aside and I write its prime factorization, which I know is 2 times 3. I take 2 aside and its prime factorization is itself. I draw a horizontal line and I find the least common denominator. The least common denominator has to have all the different factors. We have to establish the number of different factors. We have to write them, and only then we discuss exponents. Which different factors we see here?
3 squared.
So we see 2 as a factor, and we see 3 as a factor. The factor of 2 has only power 1. That's it. But factor of 3, the largest power is 2. The largest power has to be copied in the LCD. We are not adding exponents. We are only after the largest power. I have to multiply, and this is how I multiply, 9 times 2. 9 times 2 is 18. So therefore, I go back, I draw a long fraction line, I write 18, and I have to find the corresponding adjustments. Because I took the liberty to multiply 9 by something to get 18, to multiply 6 by something to get 18, and multiply 2 by something to get 18. If I do not apply the same treatment to the numerator, I've never learned algebra in my life. So, what is the adjustment for 9?
Yeah.
What is the adjustment for 6?
Three.
Very good. What is the adjustment for 2?
3 squared.
Perfect. So now, 2 times 1 minus 3 times 1 plus 9 times 1. Will you simplify with the denominator? Please say no. Screaming, screaming. Okay, good. So then, here's what I want to do. 2 minus 3 is -1. Subtracted from 9 is 8. You can say no. I want to do 2 plus 9, which is 11, minus 3, which is 8. Somebody will say no. I want 9 minus 3, which is 6, and 6 plus 2 is 8. Who cares? Addition and subtraction, as long as you make sure that 3 always, in this, any sequence you want, 3 will always have a negative in front. Because otherwise you're changing the problem. Since this is not a fully simplified fraction, and I see that 8 and 18 have a common factor, I have to pull it out. A factor from the top with a factor from the bottom. Well, it's 2, so the numerator is 4 and the denominator is 9, and this is done. Again, you can easily find whether the gibberish is the same. How will you do that? Okay, just to make sure that you're on the right track, I have 1 divided by 9, and I have minus 1 divided by 6, and then I have plus 0.5 in other words, and whatever I get, if 4 divided by 9 is not the same thing, then I'm in big trouble. It has to be the identical gibberish, and it is. Okay, so this, okay, we know how to do this. Okay, yes, I want to divide this. Okay, I'm on page 11. So we have negative 15 over 18 and divided by 3. You cannot simplify in a division. Never, unless you simplify the fraction by itself. This is extremely super important. Never simplify factors in a division. Comma, wait until you change it into a product. So never simplify factors across, you know what I mean, not the fraction by itself. Of course I'm going to simplify the fraction by itself. So negative 15 over 18 divided by 3. I don't care what I see here. I know that 15 and 18 have a common factor of 3. I will simplify that first. A factor from the top, same factor from the bottom. So I have negative 5 divided by 6. 15 divided by 5, 15 divided by 3 is 5, 18 divided by 3 is 6. And now, divided by, I will write it as 3/1, of course, because it's a fraction. 3 is the same with 3/1. Then, do not attempt anything because it's a division. Copy the first fraction, flip the second fraction, and voila, you cannot even simplify it. So simplifying this with this in a division will be a terrible mistake. You have to wait to simplify top and bottom only when you change or after you change it into a product. So then the numerator is -5, the denominator is 18. You want to check your gibberish? Yes, we can. And I'm going to show you if you simplify it, you're not going to get anything. So the original problem was negative. Remember that small negative if we, right? So put in parentheses 15 divided by 18. And then outside, divide by 3. And that's your gibberish, which has to be the same thing with -5 divided by 18 that we obtained. If it's not the same thing, it's a terrible mistake. So do not attempt to simplify the 3 and 18 because it's a division. If you do simplify 3 with 18, you will get -15/6, which will never be the final answer. So it will be -15 divided by 6 if you simplify by 3, and that will be a terrible mistake. So the point I'm making is we can simplify across top and bottom, but not in a division. And never, ever, ever in a division. You have to wait, change it into a product, and then if you can still simplify, simplify. If you cannot, this is it. So this is a crucial situation. Okay? Good, that was a good one. Okay? Same thing, do not try to simplify anything in a division. You have to wait till you change it into a product. That's what they did here. So you understand the difference. Okay? Okay, so let's choose, we still have time, let's choose another one that is a little bit more sophisticated. Like, for example, I don't know, 30. Do you want to do 30?
Looks pretty easy.
Yes. Okay. So find the perimeter. So we have to add 5/8 to 3/4, 3/4, and 5/8. So twice times this plus twice times this. We need to do this one.
I think that one's easier than 30.
Okay. Do we want to do 30? Okay, perfect. Good. So for 30, we have 1/5 plus -13/10 plus 7/5. Okay. First of all, I don't want parentheses. And I have an imaginary +1 here. And +1 times -13/10 is -13/10. So 1/5 minus 13/10 plus 7/5. I will not find the least common denominator, and you can say why. I will, but not before I'm adding these, because they have the same denominator. I want to simplify. I don't want to have to adjust 3 fractions if I can adjust just 2. So 1/5 plus 7/5 is 8/5. So I have 8/5 minus 13/10. This is again an easy situation because one denominator is a factor of the other. Nice. So what is the least common denominator? Yep. So there is only one adjustment needed, which is
8/5.
Good.
Since it's inconsistent.
16 minus 13, so this is 3/10, and that's final. Okay. I know it's a lot, but I can't really minimize anything. It's, as you see, every little thing has a little thing to talk about. Yes, I want to solve an equation like this one. Yes. I promise after this I'll stop. Okay. It's not a big deal because, as you see, all fractions have the same denominator. But the point I'm making with this problem is different. So we have 2/10 plus 20/10 equals x minus 2/10. So it is an easy situation because all denominators are the same. But I would have done, and I will show you, I will do the same thing no matter what the denominators look like. Because all of them have the same denominator, and you can say, but not this one. Okay, I agree, not that one, that's fine. I will multiply everything by 10. When I say everything, I see this, 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 and this. I cannot pick and choose. Everything has to be multiplied by 10. When I multiply this by 10, I get 2. When I multiply this by 10, I get 20. When I multiply this by 10, I get 10x. And when I multiply this by 10, I get -2. See how we should never be afraid or intimidated by fractions, ever, especially in equations. You can get rid of them in a blink. Even if you have to find the least common denominator, you can still eliminate them in a blink. So now, first I have to combine like terms on the left-hand side. You can say, why didn't you do that from the beginning? Yes, you could have. And just write 22/10. That's fine. So this is 22, and this is 10x minus 2. Of course, I'm going to move the negative term to separate the variable from the rest to the other side. I will get 24. I will get 10x. And I know that now I have to divide both sides by. That's it. We already know this. So then x equals 24/10. Yes, I have to simplify, and it's not difficult. From the top and from the bottom, they're both even numbers, so divide by 2, and I get 12/5. And that's the final answer. If I want to present it as a mixed number, I will say 2 and 2/5. That's a mixed number. This is good enough. Any questions? Okay, so let's take a look. I have 1 more minute. I want to finalize to make sure you understand what you need to do for next week. The test, if you haven't registered for the test, you may be too late. I hope that's not the case. Okay, glitches may occur. Do not wait till the last moment. So, everything has to be completed, including the practice 2.3. So from module 2, learn 2.1, practice 2.1, learn 2.2, learn 2.3, and practice 2.3. Everything till including practice 2.3 before class on Tuesday. We need to finish and get ready for the test. So we have to also review. And we still have a little bit of a chunk. Okay? So operations with mixed numbers, that will be our next adventure. Order of operations, we already did this, and this is almost done. That's 2.5. 2.6, we talk about decimal numbers and adding and subtracting decimals. multiplying and dividing decimals, and some more calculations with decimal numbers and real numbers. And that will be the end of Module 2. If you do not accomplish this by next Tuesday, you're going to have difficulties in preparing for the test. Please register for the test if you haven't done it yet. Any questions? Yes, go ahead.
On the note-taking link, it goes from notes 1.4 and it skips 1.5 and goes straight to 1.6. So when I went to submit 1.5, we don't have notes for 1.5.
Yeah, maybe there is a glitch there.
Yeah.
Okay, I'll take a look.
Thank you so much.
Thank you. So you said you said one that's
1.3 is missing. It
What?
goes from 1.4 to 1.6. There's no 1.5 in the note-taking
Okay.
thing.
okay. I'll take a look and see why. Thank you so much, Sarah.
Hello, obviously, I registered for the test, and I'm just gonna like double check on your end that I'm in the register on your end, because I remember